You're a doctor or other clinician working at an airport COVID-19 testing site, and the test you ordered for a patient comes back positive. Or you're traveling and your test comes back positive. The question is, how likely is it that you or your patient actually have COVID-19 given this positive test result? To answer this question, people often turn to sensitivity and specificity, but these are measures of how well a test performs under research conditions. Sensitivity is taking a group of people known to have COVID-19 using a gold standard test, such as a laboratory based PCR test, and then seeing of this group of people with COVID-19, how many of them will a new test, such as a rapid molecular test, correctly label as being positive for COVID-19? Whereas specificity is taking a group of people known not to have COVID-19 and seeing how many of these people will the test correctly label as being negative. In real life, it's more helpful to answer this question using predictive values, which take into account the COVID-19 prevalence in the population you come from. At this point in the pandemic, this is becoming increasingly important because the prevalence varies dramatically between different places at any point in time. And I expect this pattern of regional outbreaks of SARS-CoV-2 variants to continue in the months ahead. This matters because the test performance varies significantly based on the prevalence of COVID-19 in the population you come from. Let's say you were in India and you're flying back to the US at the end of May. You get tested at an airport testing site and your molecular SARS-CoV-2 test result comes back positive. How likely is it, given the positive test result, that you have COVID-19? If we use a sensitivity of 73% and a specificity of 99.7%, which are derived from current research on point of care molecular tests, which includes PCR tests and nucleic acid amplification tests, the type of tests that qualify for international travel requirements, and we assume a population prevalence of 10%, then using Bayes' theorem to calculate positive predictive value, we'll end up with a positive predictive value of 96%, which is pretty good. That means that given your positive test result in this example, there's a 96% chance that that positive is a true positive, meaning you actually do have COVID-19 infection. But this changes if the prevalence changes. So let's look at another example. Let's assume you're in California and you've been in California this whole time. So your population prevalence is about 0.8%. We're going to use those same test characteristics from the previous example, but now we're going to end up with a positive predictive value of 67%, which doesn't really instill a whole lot of confidence. That means that if you're a Californian and you get tested at the airport before travel, there's a 67% chance, if your test comes back positive, that you actually have COVID-19. You can see from those two examples that it makes a big difference for interpreting a test result if you come from a population with a relatively high COVID-19 prevalence or a relatively low COVID-19 prevalence. And because we're seeing these outbreaks in different countries and different regions, it's going to be really important going forward for clinicians working at testing sites or even primary care providers ordering tests for people that may be traveling or may be in a community having an outbreak to understand how to interpret these test results accurately, because interpreting medical test results is never as simple as positive, negative. There's a lot more nuance to it. And a lot of busy clinicians don't have time to sit down and calculate positive and negative predictive values and go through all of this math and research on the current prevalence, et cetera, while actually seeing patients in real life. So I hope this tool will be a rough rule of thumb guide for clinicians and for patients who are traveling to better understand if they get a positive test, how likely is it that that positive represents a true positive and they actually have COVID-19. This tool isn't perfect. It's meant to just be a rough guide to assist in the interpretation of a positive test result. I'll write more below about different caveats and considerations when using this tool. But briefly, one of the big problems is with international COVID-19 data, the international public health community only has the data that is reported. So in low-income countries where most people don't have access to COVID-19 tests and there aren't very many doctors or other clinicians who can diagnose, a lot of the cases go unreported because they weren't ever diagnosed. The public health numbers, as far as case incidence and prevalence, only pick up reported cases. So if you look at the global map, you'll see a lot of countries where you think it probably would be pretty high have really low predictive values. And that's because their reported cases are really, really low. But that probably isn't accurate. It's just because their government and health system aren't able to report very accurately. So I would recommend taking global COVID-19 data with a grain of salt, knowing that underreporting is a significant problem. And that's also true in the US. The incidence is likely much higher than what actually gets reported officially. And that does affect predictive values that are calculated using that data. So this isn't perfect, but I hope it at least will be helpful to guide clinicians when interpreting positive COVID-19 test results.